All right, so get this. Today we're going deep, deep into the world of end suction pumps.
Ooh,
I
exciting.
know, right? Okay, maybe not as exciting as like, I don't know, ancient Egypt or something.
Right.
But trust, these pumps, they're everywhere.
Yeah.
And you're here because you want to be ready when they act up.
Yeah, when they start causing trouble.
Exactly. We're going to tune you into a pump detective.
I like it.
So first things first,
Yeah.
what is an end suction pump? Like in simple terms.
Okay, so basically it's a workhorse,
Uh-huh.
uses centrifugal force to move liquids around.
Like a super fast liquid merry-go-round.
Kinda. Imagine a spinning carousel, but instead of pretty horses,
Right?
it's got an impeller with curved blades.
Okay.
And as this impeller spins, it flings the liquid outwards,
Gotcha.
creating higher pressure at the outlet, sending it on its way.
So it's all about pressure.
Pressure's key.
Makes sense. Now, of all the pump parts, which ones cause the most trouble?
Oh, good question. The usual suspects are the impeller, the bearings, and the seals.
The big three.
Yep. The impeller, that's the muscle, moves the fluid.
Uh-huh.
Bearings, think of them like the pump's joints.
Okay, keeping things moving smoothly.
Exactly. And then the seals,
Right.
those are like the pump skin, preventing leaks.
So important. Okay, let's talk problems. First up, the pump just isn't moving enough liquid.
Yeah.
What's going on there?
Well, could be a few things.
Like what?
It could be a worn-out impeller. Like, imagine a marathon runner, totally exhausted, can't keep going.
Okay, I get it.
Impeller blades can wear down over time, less efficient.
Makes sense. Anything else?
Cavitation. Air bubbles forming inside.
Cavitation, that sounds serious.
It can be. It makes a kind of gravelly sound.
Oh, I've heard that.
And those bubbles, they disrupt flow, damage the impeller.
Yikes. What else could it be?
Blockages. Like a plumbing nightmare.
Oh, no.
Debris, sediment, it all builds up, restricts the flow.
Okay, so we've got worn-out impellers, cavitation, and blockages. How do we figure out which one it is?
All right, first, you check the pump's flow rate, compare it to its specs.
Okay.
Is it way lower than it should be? That's your first clue.
Right.
Then look at the impeller itself. Does
Right.
it look worn down?
Gotcha. So gather clues. What else can we do?
Monitor those pressures,
Mhm.
suction and discharge.
Pressures?
Yep. If they're off, that's a red flag.
Okay, I'll make a note of that.
And of course, gotta check the pipes for blockages.
The glamorous part.
Sometimes, yeah.
Okay, so we've got insufficient pump performance down. Next, mystery. Excessive noise and vibration.
Oh, yeah, that one's hard to miss.
It's like a party in the pump room.
Right. Could be misalignment.
Misalignment.
Yep. If the pump and motor aren't lined up perfectly,
Okay,
lots of shaking and rattling.
gotcha. What else could be causing all that noise?
Worn bearings.
Yeah, those bearings again.
Yep, they're like R joints,
Right.
wear down over time, friction, noise, the whole deal.
Ouch. So it's basically complaining,
Yeah.
like creaky knees.
Uh-huh. Yeah, something like that.
Okay, worn bearings.
And just like before, an unbalanced impeller can cause this too.
Ah, right, like a wobbly ceiling fan.
Exactly. Anything that throws off the balance.
Speaking of throwing things off, what about those cavitation bubbles? Can they be noisy too?
Oh, absolutely. They make a distinct sound, that gravel sound.
Right, right. Okay, so we've got misalignment, worn bearings, an unbalanced impeller, cavitation, and what was the last one?
The pump's foundation.
Oh, right, the foundation.
If it's not solid, not mounted well, that
Cool.
can amplify any vibrations.
So a shaky foundation shakes everything else.
Exactly.
All right, how do we quiet down this noisy pump? What are our detective tools here?
All right, so first up, vibration analysis. Super cool, actually.
Wow.
We use special equipment to measure the vibrations.
High tech.
Totally. Helps pinpoint the source of the problem.
Nice. So it's like a pump EKG
Uh-huh. Yeah, something like that. You also want to check the bearings themselves.
visually.
Yep. Look for wear and tear and make sure that shaft alignment is perfect.
So important.
If all that looks good, then check the foundation, mounting bolts, all that.
Great advice. Okay, moving on. Mechanical seal failures. These guys are tiny but mighty,
Right.
working hard to prevent leaks. But what happens when they fail?
Well, they're delicate little things.
Yeah.
Lots of reasons they can fail.
Like what?
Most common. Improper installation.
Oh, so it's all about doing it right the first time.
Exactly. If that seal isn't installed perfectly, leak city.
Gotcha. Anything else that can cause them to fail?
Not enough lubrication.
Ah, like gears grinding together.
Exactly. It creates friction, heat, eventually failure.
So we got to keep them lubed up.
For sure.
What else?
Too much heat can damage the seal materials.
Okay, so like an overheated engine.
Yeah. And we've talked about it, but misalignment can stress the seals too.
Right, right.
And lastly, using the wrong fluids.
Oh, that's got to be bad.
It is like mixing oil and water. They just don't mix.
Makes sense.
Mm.
So how do we prevent these seal failures in the first place?
First things first, choose the right seal for the job.
Okay.
And make sure it's installed perfectly.
Precision is key.
It is.
And maintenance. How do we keep these seals happy?
Lubrication, lubrication, lubrication. Follow the manufacturer's recommendations. What type, how often.
So just like our cars, regular oil changes.
Yeah.
What else should we be watching?
Temperature. Got to make sure things aren't getting too hot.
Right. Got to keep an eye on that.
And if misalignment's a concern, deal with it right away.
So basically, give the seal lots of TLC.
Exactly.
Now, if a seal does fail, what then?
Time for a replacement. But don't go cheap.
Oh, yeah, those knockoffs.
Yeah, they might be tempting, but they'll fail faster.
Right. Better to invest in quality.
Exactly. You'll thank yourself later.
All right, let's talk cavitation. We know it's noisy and damages the impeller.
It's a troublemaker.
But can you explain more about what causes it? Why is it such a big deal?
Sure, it's all about those air bubbles.
Right, those pesky bubbles.
They form because of pressure changes.
Okay.
Like the pump's trying to drink air instead of liquid.
Ah, so it can't do its job.
Exactly. And those collapsing bubbles, they hammer the impeller.
Right, not good.
Yeah.
So what causes these bubbles to form in the first place?
A few things.
Okay, lay it on me.
Could be a poorly designed system.
Ah, so the pump's not right for the job.
Exactly. Or the pipes aren't set up right.
Makes sense.
It creates the perfect conditions for cavitation.
Okay, poor system design.
Another big one. Insufficient net positive suction head.
Whoa, hold on. That's a mouthful.
No, right? It's called NPSH for short.
NPSH, got it. What is it?
It's how much pressure is available at the pump's suction inlet.
Okay.
If there's not enough pressure.
Trouble.
Yep. The pump can't pull in enough liquid and boom, bubbles.
So low pressure at the inlet.
Yep, one of the main culprits.
Anything else to watch out for?
Pressure imbalances in the whole system.
The whole system.
Yeah, if the discharge pressure is too high or the suction pressure is too low. Bubbles again.
All right, so we know what causes cavitation.
Yeah.
How do we stop it?
Well, first, make sure the system is designed right from the start.
Makes sense. Start strong.
Right. Pick the right pump, configure the pipes properly.
Got it.
What else?
Got to make sure you have enough NPSH.
Ah, our friend NPSH.
Yep. Check the pump's requirements, make sure your system can deliver.
So basically, enough pressure at the inlet.
Exactly. You might need to adjust the pipes, raise the tank, even choose a different pump.
Okay, so we've got system design and NPSH. Anything else?
Filters and strainers.
Ah, to keep things clean.
Exactly. Prevent debris from getting into the pump.
Gotcha. So give the pump a clean diet.
Exactly.
All right, on to our final pump problem. Bearing degradation.
Those bearings again.
They're important. What happens when they start to wear out?
Well, just like our joints.
No.
They get creaky, noisy, all that.
So what are the signs? What should we be listening for?
Temperature. If the bearings are running hotter than usual, that's a bad sign.
So like the pump's running a fever.
Ah, yeah.
Okay, hot bearings. What else?
Noises, grinding, squealing, anything unusual.
So the pump is telling us it's in pain. You got it. You might also notice the shaft doesn't spin as smoothly.
What's smooth? Okay.
And of course, if you can see the bearings, look for any wear and tear.
Right, right. So basically, pay attention to any changes in the pump's behavior.
You got it.
Now, how do we keep these bearings healthy?
Proactive maintenance is key. TLC for those bearings.
Okay, break it down for us. What's this bearing TLC look like?
First up, regular lubrication.
Just like we talked about with seals.
Exacto.
Okay, regular lubrication.
And make sure you're using the right lubricant.
Ah, so it's not a one-size-fits-all situation.
Yep.
What else can we do to keep them happy?
Monitor that temperature.
Ah, like taking the pump's temperature.
Yeah, and vibration analysis can be helpful too.
Makes sense.
And last but not least, follow the manufacturer's recommendations for replacing those bearings.
So don't wait till they totally give out.
Exactly. That can cause bigger problems down the line.
So basically, be proactive.
Yes.
Yeah.
Preventative care is the best care.
I like it. Okay, so we've covered the common problems.
The basics.
Right. But what if we encounter something more complex? A real pump mystery.
Ah, the tricky ones. That's where advanced troubleshooting comes in.
Ooh, I'm intrigued. Tell me more.
Well, it's all about being systematic.
Systematic, okay.
First, you do a thorough initial assessment.
Assessment, what does that involve?
Gather all the info you can. Pump history, operating conditions, Maintenance records.
So like a pump's medical history.
Exactly. Talk to the people who run it, maintain it.
Gotcha. So gather intel before even touching the pump.
Yep. Then you need hard data. Flow rates, pressures, temperatures, vibration levels, everything.
Wow, so it's like giving the pump a full physical.
Exactly. Then, time for a systematic inspection. Look at every component. Look for anything unusual.
So we're looking for clues.
You got it. Sometimes you need special tools, like non-destructive testing.
Fancy.
It's like x-rays for pumps.
That's so cool. So advanced troubleshooting is like a mix of detective work and high-tech analysis.
The best of both worlds.
I love it. What happens once we've finished the inspection?
Time for root cause analysis. This is where you put your detective hat back on.
Okay, I'm ready.
You got to figure out why the problem's happening.
So we're not just fixing the symptom, we're finding the root cause.
Exactly. Once you know that, you can fix it properly. A&D prevent it from happening again.
This all sounds very thorough.
Yeah.
I feel like we've given our listener a superpower.
I think so too. Knowledge is power. Right?
Absolutely. But before we wrap up this part, let's talk prevention.
The best medicine.
Right. It's better to prevent a problem than to fix it.
100%.
So give us the golden rules of pump prevention.
Okay, the foundation. Regular maintenance.
Makes sense, just like our own health.
Exactly. And crucial point, make sure the people maintaining these pumps know what they're doing.
Training. So important.
It is. Invest in your team.
Right.
Make sure they understand these pumps inside and out.
Got it. Now, you mentioned technology earlier. How can tech help us prevent problems?
Condition monitoring. It's a game changer.
Condition monitoring. Okay, what is it?
Think of it like a fitness tracker, but for your pump.
A pump Fitbit.
Haha, exactly. It's constantly monitoring its health, alerts you to any issues.
Wow, like a 247 pump bodyguard.
Exactly.
What kind of tech are we talking about?
There's a whole range. From simple vibration sensors to super sophisticated systems,
Right.
They can monitor temperature, pressure, flow, even the fluid's chemical makeup.
No way. So they're constantly taking the pump's pulse, looking for trouble.
Yep. And they can be customized, they can send alerts, even shut down the pump automatically.
Wow, that's amazing. Like a safety net?
It is, but don't forget about good old-fashioned record keeping.
Wait, you mean keeping a logbook?
Yep. A detailed operational log is essential.
Okay.
Think of it like a pump diary.
Uh-huh. A pump diary. What do we write in it?
Everything. Operating hours, maintenance, anything unusual, repairs, parts replaced.
Wow, so like a complete history of the pump's life.
Exactly. Helps you spot trends, potential problems early on.
Makes sense. Are there any systems that can help us keep track of all this? It sounds like a lot of info.
Oh yeah, tons of software programs for that. They automate a lot of the work.
That's great. So tech can really help us out here.
Big time.
Any other tips for keeping those pumps in tip-top shape?
Yep, don't skimp on replacement parts.
Ah, right. Quality over quantity.
Exactly. Always use high-quality parts, meet the manufacturer's specs.
So invest in those good parts. It'll pay off in the long run.
Absolutely. And lastly, regular system audits.
System audits. Okay, what are those?
Basically, you take a step back, look at the entire system.
The whole shebang.
Yep. The pump, pipes, valves, controls, everything.
Wow, so it's like a full-body checkup for the whole system.
Exactly. You're looking for potential problems.
Smart. Catch those issues before they become big problems.
Precisely.
Amazing. We've covered so much ground here. I feel like we've given our listener a whole toolbox for dealing with pumps.
I agree. And hopefully they feel a lot more confident about tackling those challenges.
Right. It's all about knowledge,
Mhm.
and with little detective work, anyone can be a pump whisperer.
I love that.
Oh.
A pump whisperer.
And that's just the beginning. In the next part of our deep dive, we're going to explore something even more fascinating, the human element.
Ooh, can't wait.
It's going to be good.
You know, when we were talking about prevention earlier, it really got me thinking
Yeah.
about how many pump problems, like so many, could be avoided.
Right.
Just with a little bit of, planning ahead.
Thinking ahead for sure.
It's like anything else, right?
Really.
A little TLC goes a long way.
It really does. And it's easy to forget about these pumps,
Oh, absolutely.
out of sight, out of mind.
Yep. Until they stop working.
Exactly. And then it's panic mode.
Right. But a little preventative care
Uh-huh.
can save you so much trouble down the road.
Totally. And probably a ton of money too.
Oh, yeah, for sure. And the best part is,
Yeah.
setting up a good preventative maintenance routine, it's not rocket science.
Right. Doesn't have to be complicated.
Nope.
So let's break it down. What does a solid preventative maintenance program look like?
All right, so the foundation is a regular maintenance schedule.
Okay, so like scheduling those checkups.
Exactly, just like you would for your car.
Or even for yourself, right?
Uh-huh.
Got to get those yearly physicals.
Exactly. Your pump needs those checkups too.
Makes sense.
So we're talking routine inspections, lubrication, adjustments,
Mhm.
all based on, the manufacturer's recommendations
Right.
and the specific conditions that your pump is operating under.
So we need a personalized plan for each pump.
Exactly. One size does not fit all.
Gotcha. And you mentioned training earlier.
Oh, yes.
Yeah.
So important.
Crucial.
The people who are actually taking care of these pumps,
Yeah.
they need to know what they're doing.
Right. Can't just hand someone a wrench and say, good luck.
Exactly. Invest in your team.
Mm-hmm.
Make sure they're trained properly.
Trained on those specific pumps.
Yep.
Okay, so regular maintenance, well-trained crew, we've got the basics.
The foundation.
Now let's add some tech into the mix.
Ooh, yes.
You mentioned condition monitoring earlier. How can technology help us prevent pump problems?
All right, so condition monitoring, it's like game-changing.
Okay, I'm intrigued. Tell me more.
It's like having a fitness tracker, but for your pump.
A pump Fitbit. I love it.
Right. It's constantly monitoring the pump's health, looking for any signs of trouble.
Wow, so it's like a 247 pump bodyguard?
Exactly.
What kind of technology are we talking about here?
Oh, there's a whole range of options.
Like what?
You've got simple vibration sensors.
Okay.
You can just attach those right to the pump.
Uh-huh.
And then you've got more sophisticated systems
Okay.
that can monitor all sorts of things.
Like what?
Temperature, pressure, flow,
Wow.
even the chemical composition of the fluid.
No way. So it's like taking the pump's pulse, looking for any irregularities.
Exactly. And the best part,
Yeah.
these systems can be customized.
Yep.
You can set them up to send you alerts.
So you know right away if there's a problem.
Yep. Or even shut down the pump automatically.
Whoa, really?
If certain thresholds are exceeded.
So it's like a safety net.
Exactly.
Yeah.
Prevents those catastrophic failures.
That's incredible. Technology is amazing.
It is. But, don't underestimate the power of good old-fashioned record keeping.
Wait, you mean like keeping a logbook?
Yeah. A detailed operational log.
Okay.
It's essential.
What kind of stuff do we need to record?
Everything. Operating hours, maintenance performed,
Uh-huh.
any unusual events,
Okay.
repairs, parts replaced.
Wow, so it's like a complete history of the pump's life.
Exactly.
It sounds like a lot to keep track of.
It can be, but it's worth it. Trust me.
Why? What are the benefits?
Well, those logs, they can help you spot trends.
Trends.
So you can identify potential problems early on.
Before they become big problems.
Exactly.
Makes sense. Are there any tools that can help us manage all this information?
Oh, yeah, for sure. There are tons of software programs out there.
Okay.
Specifically designed for managing maintenance logs.
So they can kind of automate the process.
Exactly.
That's awesome. So technology can really be our friend when it comes to pump prevention.
Big time.
Any other tips you can share?
Let's see. Oh, replacement parts.
Oh, yeah. Those are important.
When it's time to replace a part, don't skimp on quality.
Right. You get what you pay for.
Exactly.
Yeah.
Always use high-quality parts.
Mhm.
Make sure they meet the manufacturer's specs.
So invest in those good parts. It'll save you headaches down the road.
Absolutely. And one last thing.
Okay, hit me.
Regular system audits.
System audits, what are those?
Basically, you're taking a step back,
Okay.
looking at the entire system.
The whole shebang.
Yep. Pump, pipes, valves, controls, everything.
So it's like a full body checkup for the entire system.
Exactly. You're looking for any potential problems.
So you can catch them early.
Yep.
Yep.
Before they turn into big, expensive headaches.
This is all great advice. So it's not just about fixing problems when they arise.
Yep.
It's about being proactive and keeping those pumps healthy.
Exactly. Prevention is key.
I like it. Okay, so we've talked a lot about the mechanics of pumps and preventative care.
Yeah.
But let's be real.
Okay.
Sometimes the biggest challenge isn't the pump itself.
Uh-oh. I know where you're going with this.
It's us, the human element.
The human factor, so true.
All right, let's talk about this human factor.
Okay.
What are some common ways we humans mess things up?
Oh, there are so many ways.
Like what? Give me some examples.
Improper installation.
Ah, yeah, that's a big one.
Neglecting maintenance. Miscommunication.
Between operators and technicians, right?
Yep. Even something as simple as using the wrong lubricant.
Oh, yeah, those little details can make a big difference.
Huge difference.
So it's not always the pump's fault when things go wrong.
Nope. Sometimes we need to take a look in the mirror.
And be honest with ourselves.
Exactly. And this is where things get really interesting.
Okay, tell me more.
Troubleshooting isn't just about inspecting parts and analyzing data. It's also about understanding the people involved.
The human element.
Exactly. And how their actions might be impacting the pump's performance.
So it's like being a pump detective.
Yeah.
Andy, a people detective.
I love that. You have to ask questions.
Like what?
Who installed this pump? Was it done correctly? Who's responsible for maintenance? Are they following procedures?
Wow, those are great questions.
Yeah.
I can see how understanding the human element can be just as important as the technical stuff.
Oh, absolutely. And it's not just about preventing problems. It's also about optimizing performance.
Ah, right, getting the most out of those pumps.
Exactly. By paying attention to the human factor, you can identify opportunities to improve things.
Like what?
Operating procedures, maintenance tasks,
Okay.
make everything more efficient, more reliable.
So it's like we're taking a holistic approach.
Exactly. Considering both the technical and the human sides of the equation.
I love it. This is fascinating. It's like we've added a whole new dimension to pump troubleshooting.
It really is.
And I have a feeling this human element is going to be key to solving a particularly tricky pump mystery.
Oh, a mystery. Tell me more.
All right, so picture this. There's this amazing pump expert.
Okay.
Let's call her Sarah.
Sarah.
Sarah gets a call from a plant,
Uh-huh.
and they're having major problems with one of their pumps.
What kind of problem?
This pump is vibrating like crazy,
Oh, yeah.
making all sorts of horrible noises,
Not good.
and it's just not performing the way it should.
It sounds like a mess.
It was. They had called in other technicians,
Uh-huh.
but no one could figure out what was wrong.
So they called Sarah the super sleuth.
Exactly, hoping she could crack the case.
What did she find?
Well, they had checked everything.
Really? Everything.
Impeller, bearings, seals, alignment, the foundation, everything.
Wow, and nothing seemed out of place.
Nope, they were stumped.
So what did Sarah do?
Well, Sarah, she's a big believer in that holistic approach.
Right, considering all the factors.
Exactly. So she started asking questions.
Questions.
You talked to the operators, the maintenance guys, even the engineers who designed the system.
Wow, she was thorough.
She was. And slowly but surely,
Yeah.
a pattern started to emerge.
Ooh, I'm on the edge of my seat. What did she discover?
It turned out that the plant had recently switched to a new type of lubricant.
Lubricant. Okay.
For the pump.
Uh-huh.
They thought it was a compatible replacement
Okay.
for the one recommended by the manufacturer,
Right.
but it wasn't.
Oh.
This new lubricant, it was a little bit thicker,
Thicker. Okay.
and over time, it started to gum up the bearings.
Ah, so the lubricant was the culprit.
Exactly. The pump itself was fine,
Wow.
but that one little change
Uh-huh.
had thrown everything off.
A classic case of human error.
Exactly.
Hmm.
It highlights how important it is to consider every aspect of the system.
The human element included.
Absolutely.
That's a great example. It shows that even experienced technicians can miss things
Right.
if they're only focused on the mechanics.
And not the people involved.
Exactly.
It's a reminder that we need to keep our minds open
To all possibilities.
when we're troubleshooting pumps.
And sometimes the answer is right there in front of us.
We just need to know where to look.
Well said. Sarah's story is like a perfect lesson.
It is.
Right. Reminds us to look at everything when troubleshooting.
Absolutely.
Not enough to just know the pump parts, how they work.
Uh-huh.
You got to understand the people running those pumps too.
Yeah, the human element.
Exactly. It's about the big picture.
The big picture.
The pump's just one part of a bigger system.
Right.
To really get it, you got to see all the factors.
All the factors on
The
it.
human factor is huge.
Okay, I'm liking this. So we're like expanding what it means to be a pump expert.
Totally.
It's not just the technical stuff.
Right.
It's communication, observation, even a little psychology.
Ooh, I like that. Pump psychology.
Right. And think about it.
Okay.
When you get the human element,
Uh-huh.
you can prevent so many problems.
Before they even happen.
Exactly.
Create a culture of like open communication,
Okay.
clear procedures, good training. You cut down on human error like crazy.
So it's about creating a work environment where everyone's on board.
On the same page.
Right. Everyone understands how to take care of those pumps.
Yep. It's teamwork.
Teamwork makes the dream work.
Aha. Exactly.
And that saves everyone a lot of headaches down the line.
Oh, for sure. Time, money, stress, all of it.
It's a win-win.
Totally.
You know, this has been eye-opening for me.
Yeah.
Pump troubleshooting is way more complex than I thought.
Kitty.
It really is. It's not just nuts and bolts. It's about systems, people, the whole interconnected web.
I love that. Interconnected web.
It's fascinating.
It is. And that's what keeps it interesting. Right?
Totally. Always something new to learn.
Every challenge is a chance to grow.
I couldn't agree more. And speaking of learning,
Yeah.
We've covered a lot of ground today,
Who have?
from pump basics to troubleshooting tricks, even that human element.
The whole enchilada.
Right. Hopefully our listener is feeling pump savvy now.
Pump savvy, I love it.
Yeah. Ready to tackle any pump problem that comes their way.
With a little detective work, anyone can be a pump whisperer.
Exactly. And remember, folks,
Yeah.
keep that human element in mind.
Sometimes the answer's not in the machine.
Right.
It's in the people using it.
Wise words. Well, that's a wrap for this deep dive. We had a blast exploring the world of end suction pumps.
Me too.
Hope you learned a thing or two.
Always something new to discover.
Until next time, stay curious, keep those pumps running, and don't forget that human element.